What? A supermassive black hole in the center of our galaxy disappeared? Oh, okay. Well, I suppose I have to explain why I don't seem to be worried. And obviously I should clarify that it's just a hypothetical scenario. Some people might think that it's because the center of galaxy is some 25,000 light years away, so we would still have a lot of time left. But if we could see that it disappeared with our telescopes, gravitational influence would also have reached us by that time. But that doesn't really matter. But even if there existed a way to learn about disappearance of a black hole in real time, without the speed limit of light, and in the case that if we learned about it 25,000 years later after the actual event, we wouldn't have to worry that much. So today I'm gonna talk about this hypothetical scenario, also about the link between masses of black holes and their host galaxies, about stellar motions, and about whether there can be galaxies with no supermassive black holes. My name is Andrei, and this is Cosmos Elementary. The Moon orbits the Earth. The Earth orbits the Sun. The Sun orbits... In my video on submoons, I said that there were 3 links in that chain: a moon, a planet, a star. Back then I was talking specifically about the solar system, but I frequently see people comment that there is a 4th element, and that the Sun orbits a supermassive black hole. And that's not quite correct. Well, yeah, our Sun and other stars move in orbits around the center of the Milky Way. And yes, there is a black hole in the center. It may appear as if it is the same as Earth orbiting the Sun, but on a larger scale. But that's not true. If in a simple model we delete the Sun, this will happen. Well, not all of the planets will do this instantaneously, but still. Using the same logic, one might think that if the supermassive black hole disappeared from the center of galaxy, this would happen. Yeah, that's actually a good example of how models like this one don't show everything realistically. No, a galaxy shouldn't fly apart. For the same reason, it's incorrect to say that the Sun orbits the black hole. Comparing 2 systems, the solar system and the galaxy, we have to look at masses. The Sun is 99.8% of the whole mass of the solar system. It dominates the system and it governs the movement of all of the objects. We don't know the exact mass of the Milky Way, but it is estimated to be up to 1.5 trillion solar masses, if we include dark matter. While the mass of the central black hole, Sagittarius A star, is a little over 4 million solar masses. Black hole's mass is only this much of the galaxy's mass. The Sun is basically the solar system, whereas the black hole is just a tiny fraction of the mass of the galaxy. Well, yeah, there are stars that actually orbit the central black hole, a bit like Earth orbits the Sun, a group of S stars. Decades-long observations of those stars, the way they orbit an invisible object, are among the main pieces of evidence for the existence of a black hole in the center of our galaxy. The data also allowed scientists to calculate the mass of the object. But the further you get from the central black hole, the less significant is its gravitational influence on stars. Even if we hide stars in a 3D model and leave it to show only the supermassive black hole and the Sun, it will look like the Sun is orbiting the black hole, but in practice you can't ignore the rest of the mass. That's why it's more appropriate to say that the Sun orbits the center of the galaxy. And because the supermassive black hole is only a small fraction of the combined mass that defines the structure of our galaxy, even if it disappeared, there would be some effect, but the whole galaxy wouldn't fly apart. And the Sun, which is quite far from the galactic center, would keep moving in its orbit around it. Unlike Earth, which would leave the solar system if the Sun disappeared. It is more difficult to understand how it works in such a complicated system as a galaxy. Unlike the solar system, which has an obvious dominant massive object. So we can use a smaller example. Actually, even to say that Earth orbits the Sun is not completely correct, and I'm not even touching reference frames. What I mean is that 2 bodies orbit the center of mass. The most obvious example is a system of 2 bodies of the same mass. Here is the barycenter, and both bodies orbit that point. The barycenter of the Sun-Earth system is actually not in the center of the Sun. yet it's still inside the Sun. But in the system of the Sun and Jupiter, this point is outside the surface of the Sun. These are examples of simple systems. Something bigger but not quite as big as a galaxy are globular clusters. By the way, I have a whole separate video on them. They are spherical large groups of stars bound by gravity. These animations show how stars in such clusters move. The movement is governed by the combined gravity of the whole cluster and also interactions of individual stars with each other. Yes, it has long been supposed that there could be intermediate mass black holes in the centers of such clusters. But for now, only a few candidates for such objects are known. And recently there was a study about the cluster NGC 6397. Scientists discovered there not a single intermediate mass black hole, but rather a whole cluster of stellar mass black holes. Anyway, it is possible that some of such clusters don't have more massive black holes in their centers, and yet they don't fly apart because of the collective gravity of all of the stars. So without a supermassive black hole, the galaxy wouldn't fly apart. But it would fly apart without dark matter. Actually, the fact that the galaxy is not flying apart, and also how velocities of stars are distributed, is one of the main pieces of evidence for dark matter. Usually there is more dark matter in galaxies than regular matter, so we have figured out that even if the black hole disappeared, the whole galaxy wouldn't get destroyed. So, can there be a large galaxy with no black hole at all? Whenever I talk about supermassive black holes, I usually say something like this. There is a supermassive black hole in the center of almost every large galaxy. There is a reason why I say almost every galaxy. There are several reasons why scientists think that they are present in most of large galaxies. Observations of stars and gas clouds and the close proximity of supermassive black holes, observations of active galactic nuclei, evolutionary models of galaxies, and of course, this EHT image. All of this and a lot more tells us that statistically there should be supermassive black holes in most of the galaxies. And yet, when astronomers look at some galaxies, they don't see black holes in each and every one. For instance, a galaxy in the center of Abell 2261 cluster. It's been studied for decades and scientists still struggle to find a black hole in it. But this galaxy is quite far away. I mean, really far away. 2.7 billion light-years away. Perhaps we haven't found its black hole because of some technological limitations. But is there anything closer? Actually, there is. A nearby galaxy that might not have a supermassive black hole is well known with amateur astronomers and astrophotographers. This is M33 or Triangulum galaxy. By the way, this photograph was made by my friend. It is the third most massive galaxy in our local group and it's only 2.7 million light-years away. Sometimes it's even visible with the naked eye. The fact that it's relatively close to us allows modern telescopes to resolve millions of individual stars in that galaxy. This in turn allows scientists to study motions of stars and find out if there is a black hole there. And it looks like it's not there. So how do we know that? I've already mentioned the fact that generally stars and galaxies don't behave the way astronomers expected them to decades ago. They used to think that galaxies should work in a similar way to planetary systems. The further the star from the center, the slower it moves in its orbit. For instance, the orbital velocity of Mercury is 47 kilometers per second, which is 1.5 times faster than the Earth's orbital velocity. But for galaxies, this turned out to be not true. Velocities of stars don't decline with distance. Now it's explained with the dark matter. But anyway, much closer to a black hole, where it starts to show significant gravitational influence, such velocity increase should happen. And it does. The orbital velocity of most stars in the Milky Way is about 200–250 kilometers per second. But the stars that are closest to the black hole move really fast. According to the measurements of the gravity instrument on the Very Large Telescope, the orbital velocity of the S2 star can reach up to 7,600 kilometers per second, which is 3% of the speed of light. This animation of actual images of actual stars orbiting an invisible object continues to amaze me. So in our galaxy, close to the supermassive black hole, velocities of stars significantly increase. But in the Triangulum galaxy, scientists didn't see such an increase of velocities of central stars. Authors of this study concluded that if black hole exists there, its mass can be higher than 3,000 solar masses. Let me remind you that a supermassive black hole in our galaxy is over 4 million solar masses. Sure, M33 is several times less massive than the Milky Way, but still, it's hard to call it a supermassive black hole. This study sets the upper limit of 1500 solar masses, and the lower limit is 0. 0 solar masses. In other words, there might be no central black hole at all. And yet this spiral galaxy obviously exists and doesn't fly apart, but still, this galaxy is a bit different. The Milky Way and many other spiral galaxies have this thick structure in the middle, known as bulge. These structures have higher stellar density. The center of Triangulum galaxy is brighter, but the bulge is basically lacking. And the reason may be a non-existent central black hole. You might start thinking that black holes don't seem to be that important after all, which is of course not true. Authors of the last study I mentioned conclude that supermassive black holes affect not galactic disks, but rather bulges. There is an observed link between properties of supermassive black holes and evolution of galaxies. Let's look at this graph. We can see how growth of the mass of the central black hole and the stellar mass of a galaxy correlate. It's been long thought that there is some link between masses of black holes and their host galaxies. For instance, there is a certain relation between the mass of a black hole and stellar mass of a galaxy. It's actually still not completely understood. As we know, the mass of the black hole is just a fraction of the whole mass of the galaxy, and most stars don't even know that there is a black hole. If we talk about a bulge, it's usually said that the mass of a supermassive black hole is 1,000th of the mass of a bulge. This is typical for many galaxies. Perhaps there is a link between formation of bulges and supermassive black holes. There are of course many factors that affect the evolution of galaxies, one of which is black hole activity. When a black hole is actively accreting matter which heats up to immense temperatures, it creates a lot of strong radiation, winds appear, and also particles accelerate to immense speeds in jets. And that can have an effect across thousands of light years, which is much farther than the measurable gravitational influence of a black hole. So it pulls a lot of material away rather than just pulls it. This can halt star formation in the galaxy. But of course, it's not the only process that can stop star formation in a galaxy. Also, it can be affected by interaction of galaxies, and there can be other factors. Supermassive black holes are often counterintuitive. Some people say that their average density is less than that of water, which is not quite correct to say, but still. I have a whole separate video on that topic. They're not dominant across their galaxies, and they can push away more matter than pull in. And still, it's hard to underestimate their influence on the evolution of galaxies, even though it hasn't been completely understood yet. Thanks for watching. Links to all of the sources are down below in the description, and if you enjoyed the video, leave a like, comment and subscribe. Bye!